Hey, how's it going, everybody? My name is Max Browerman, and today I'm going to be presenting on personal air sampling and specifically using Casella pumps. But I know the theme today is NASCAR, so I thought I'd start off with a little NASCAR joke. I'm not sure if any of you know how NASCAR got its name, but actually it was just two guys showing up to the track, and one guy said to the other, "Hey, that's a NASCAR you got there. It's a real NASCAR." And actually, you're legally required to laugh at my jokes today if you want credit for the 8-hour Haswhopper. So I better see a lot of LOLs in chat or something like that. So a bit about myself. I went to The Ohio State University for my undergraduate degree. You can see me there testing out the diploma to see if it's real. I studied chemical engineering while I was at Ohio State. And then after that, I went to the University of Iowa to get my master's in environmental engineering and my MBA as well. And ever since then, I've been working full-time here at Field Environmental, which has been 4 years and change now. So back to the topic at hand, air sampling. It's basically just a way to determine the amount or concentration of contaminants in the air. Oftentimes for personal air sampling, this is done using a pump that is attached at the belt or a harness, and then some inlet tubing run up to a filter maybe, and then at the respirable zone. So that's considered, 30 centimeters anywhere around the mouth or nose area. Some of the calculations that they'll do for air sampling, personal air sampling, is trying to find the volume, which is just done by the flow rate of your pump times the amount of time that the run was performed. And then they'll use that volume to help find the concentration. So oftentimes there's a filter in line with that pump, and the filter will be sent off to a lab where they'll measure the mass of the contaminant that they're looking for. And so that mass divided by the volume gives you the concentration. And that concentration can be used to help find time-weighted averages. And that's oftentimes what you're gauging against for regulatory limits. And so to find the time-weighted average, you have the concentration multiplied by the time that concentration was present. So say you had an 8-hour run, and for 6 hours you were at 10 milligrams per liter, and for 2 hours you're at 0 milligrams per liter of contamination. When you plug that into this formula, you're going to end up getting an 8-hour time-weighted average of 7.5 milligrams per liter. So like I said, in personal air sampling, a lot of times you're using filter media to determine concentration, and those are housed in different types of filters. So I thought it was worthwhile to go over a couple of the different types of filters first. This is the most basic type of filter. It's just a two-piece filter. You can kind of see this diagram breakdown where there's an inlet, it goes to the media, and then there's a little support for the media, and then the outlet. So really just two pieces sandwiching the filter media in between them. So very similar to the two-piece filter, this is the three-piece filter. So the only difference here is there's an extra piece of plastic in there that's going to help sandwich that filter in there. Oftentimes what this is used for is with cyclones. So say you were measuring for something that had a specific cut point and you wanted a certain size of particle and below, you could use this with a cyclone to get to that lower particle sizes compared to what you would need for the two-piece filter. So on top of having different types of filters, you also have different types of filter media. So here I've just given some examples of common types of filter media that could go into those 2 or 3 piece filters. That can range really anywhere from like glass fiber, which measures for things like isocyanates or ethylene glycol. You've got PTFE, which is like alkaline dusts, or PAH is the polyaromatic hydrocarbons. Quartz, oftentimes it's best used as at higher temperatures or for stack sampling. And then also, of course, you've got the paper or synthetic mesh filters, which are really best for turning left at 200 miles per hour. So one thing to note with the different types of filter media is they do have different porosities, which will then lead to different back pressures when you're sampling. So things like MCE at 0.45 micron, that's the pore size, that's gonna be really small, and that's gonna build back pressure really quickly as the pump is trying to draw air through the filter. Things like PVC that maybe aren't so dense, don't have quite as small pores, will let air through a little bit easier, and you won't generate as much back pressure. And of course, back pressure is something that's really important when you're sampling, because that can affect how well your pump is running, how long you need to run for to get to a certain mass of your contaminant, things like that. And back pressure can be affected by other things like the type of tubing you're using or maybe like friction inside the pump. But by and large, I would say the biggest factor is always going to be your filter media. So aside from filters and filter media, another popular use of personal air sampling is using sorbent tubes. And sorbent tubes are really good for measuring toxic gases and vapors, just because those are more of a chemical reaction, so that as air is drawn through a sorbent tube using a personal sampling pump, that reagent inside the sorbent tube will react with a contaminant in the air, and then you can send the sorbent off to the lab to figure out how much of that contaminant was in fact reacted inside the sorbent tube. So with all the air sampling stuff being covered so far, now I want to talk more about the pumps, in particular the Casella Apex 2. So the Apex 2 is probably something that you're most familiar with just because it has the most versatile range of flow rates. You can see here kind of what I was talking about, where you're going to mount this on your belt and then run an inlet line up to your respiratory range. And you can see kind of how easy the interface is to look at, as well as what it might look like actually while you're wearing it. So the Apex 2 can be used for a whole lot of different personal sampling applications. A lot of your flow rates and filter medias are going to be determined by what you're looking for and what you're sampling for, as well as the methods that you're following. But the Apex 2 can really match a lot of those different methods. The flow rate for the Apex 2 can range anywhere from 1,000 to 5,000 milliliters per minute. And that's typically at plus or minus 5% of your calibration point, just because the pump will oscillate as it's running. One thing to note though is the Apex 2 can get down to those lower ranges, the 5 to 500 milliliters per minute range, but that does require an adapter, which is just something that you would run in line between the Apex 2 and your filter. I also think that the Apex 2 is incredibly user-friendly. I think it's very intuitive to use. You can kind of see what the interface here looks like. There's just an up and down button, a power button, and an enter button. So cycling through settings is really easy. And if you're familiar with other types of personal air sampling pumps out there that maybe have set screws or more analog adjustments, I think that the Apex 2 is way easier to use and way more friendly for people out in the field compared to some of those other pumps. The Apex 2 is also built for all-day wear. So it's pretty lightweight, coming in at only 17 ounces. Just to put that in reference for you, one Kyle Busch is worth about 185 Apex 2s weight-wise. So aside from being lightweight, the Apex 2 is also nice and compact size-wise, measuring about 4 inches tall by 4.5 inches wide. It would take you about 35,200 Apex 2s to make one lap of the Daytona 500. And for those of you wondering if that's actually 35,200 Apex 2s there on the screen, maybe just worry about yourself. So when it comes to the battery life of the Apex 2, it's pretty robust. In fact, Casella says that in perfect conditions at the lowest flow rate and no back pressure at all, the battery should last over 50 hours. But that's perfect conditions. We all live in the real world where that's never going to happen. You might be outside where it's freezing cold or too hot. You've got filters running in line. You might be running duplicates, who knows? But likely what you're going to see is somewhere in this range on the graph, depending on what your flow rate is. But one thing that I do want to point out is that back pressure has a huge impact on battery life when it comes to the Apex 2. As you can see on this table, like when you only have about 20 inches of water in back pressure, your pump can last for 35 hours. But once you up that back pressure at about 80 inches of water, you're only looking at like 12 hours of battery life. So whenever you're planning your sample, make sure you're thinking about what filter media am I using? How long do I need this sample to last for? Because depending on those different things, depending on what your flow rate might be, you might not have enough battery to last for your entire sample. Calibration with the Apex 2 is also super simple. There's those up and down arrows that I mentioned once you get into the calibration menu to just increase or decrease your flow compared to what is reading on your calibrator. But one thing that I do want to point out is that if you have the Casella Flow Detective and Casella Airwave, their app that you can download to iOS or Android, you can actually run the calibration from your phone. So here you can kind of see what that calibration would look like on your phone. On the Airwave app, on the left, you can kind of see the Flow Detective and the Apex 2 showing up in Airwave. Once you click on the Flow Detective, it will take you to this screen, the middle screen, where you can select which Apex 2 you want to calibrate, just in case you have more than one. And then once you've got your Apex 2 selected, you can set your flow rate to whatever you need it to be and just hit the calibrate button, and they will run via Bluetooth and calibrate automatically for you. One other benefit of using Casella Airwave and the Flow Detective is that all those statistics from calibration can be exported really easily. Straight from the app, you can input an email address and it will send off that data along with things like run statistics, whether there were any faults during your run, all that sort of stuff will be emailed straight to you in an Excel format, kind of like what you're seeing here on the right. So if you need to run some low flow air sampling, rather than using the Apex 2, one other option that you have is to use the Vapex Pro. So where the Apex 2 kind of hits that middle ground of flow rates, that 1,000 to 5,000 milliliters per minute, the Vapex Pro runs lower than that. It will run at 20 to 500 milliliters per minute without any adapters necessary. The Vapex Pro is also super easy to use. In fact, Casella is really consistent when it comes to their user interface. So the buttons are pretty much the same. The calibration menu is pretty much the same. So once you learn one of these pumps, you really have learned all of them because they're all the same to use for the most part, aside from just the flow rate and, like the size of them. So similar to the Apex 2, the Vapex Pro also has a really robust battery life. In fact, because it's running at lower flow rates than the Apex 2, it actually outperforms the Apex 2 when it comes to battery life. One thing I do want to mention though is the effects of back pressure aren't as pronounced on the battery life of the Vapex Pro. The Vapex Pro probably deals more with flow rate when it comes to battery life than anything else. Just going based on this graph, as you can see here, even at the highest back pressure for the 100 milliliters per minute run, you're still going to get more battery life than what you would see off the lowest back pressure off of like the 300 milliliters per minute run. The Vapex Pro is also really compact and lightweight and really built for all day wear. It's not going to be something that's going to drag your belt down while you're wearing it. Weighing it at only like 7.7 ounces, it would take 330 Vapex Pros to be the equivalent of one Ricky Bobby, the winner of the Talladega 500. The Vapex Pro is also compatible with Casella Airwave, so that calibration procedure that we spoke about earlier that you can do from your phone, you can do that with the Vapex Pro as well. Same as exporting all that data, all that good stuff that's available with the Apex 2, you can do with the Vapex Pro. One other pump that I wanted to mention today is the Vortex 3. This is kind of like the high flow pump for the Casella family. It's not necessarily something that's going to be used for personal air sampling all that often, just because it's a bit bulkier, it's a bit heavier. Typically, it's meant for like stationary air sampling. So like you can see in this picture here, someone setting it up on the floor with a stand to measure at respirable height. This is something that you would kind of set and leave rather than wear on your belt. So here you can see the interface on the Vortex 3. It's pretty much the same interface that we have on the Vapex Pro as well as the Apex 2. Like I said, super consistent. The Vortex 3 is also compatible with Casella Airwave as well. So just some Vortex 3 specs. They weigh in closer to like 4.5 pounds compared to the other two lighter pumps. And they'll also only last around like 2.5 hours at 12 liters per minute, which is their max flow rate. But that makes sense given how intense the pump draw is when you're up at those higher flow rates. And so for those of you that need a little reference for how much the Vortex 3 weighs, this is Lightning McQueen, winner of the Piston Cup, well known all over the world. To get the equivalent in weight of one Lightning McQueen, you would need 825 Vortex 3s. And if you're curious about how I found out the weight of Lightning McQueen, it pays to know people. So with that, I just want to thank you all for listening to my talk on personal air sampling, in specific using Casella pumps. I also want to thank you all for laughing at all my jokes. I just want to let you know that I will be diving into the chat after this just to see who in fact has been like sending the laughing face emojis. And then I'll be sending out your credits according to who's been laughing. So thank you all. Have a good rest of your day.